We want to factor this completely. Now the numbers are large, so we'd hope for a greatest common factor, but there isn't one. That means that we have to try breaking this down as a trinomial. Now with factoring, we look for squares and cubes quite a bit, so you might recognize 36 and 49 are perfect squares. And so a possibility is to use the 6x and 6x square roots and 7 and 7 as the square roots of 49. But if this doesn't work, we'll still have to consider all other possible ways to factor 36 and 49. With 49, the only other one is 49 times 1, so that's not too bad. 36, we're going to have all kinds of possibilities, like 9 times 4, or which also gives us 4 times 9, or 12 times 3 and 3 times 12, or we got 9 times 4, 6 times 6, 12 times 3. Well, if none of those work, we can look for any others. We can see the last sign's positive, so that means both our signs will be the same. The first sign's negative, so they'll both be negative. So what we're hoping for is, because those are perfect squares, we're hoping this is a perfect square trinomial. And in which case we can see that 7 times 6 is 42. So we have a negative 42x. Negative 84 is twice that, because the outer terms are also negative 42x. So we can see it is indeed a perfect square trinomial. And so we can either recognize that right off the bat or try all the different ways to factor a trinomial. Either way, you should hopefully come up with the factor of 6x minus 7. And that quantity is squared because both factors are the same. So if you recognize those perfect squares, that can really simplify your trinomial factoring. But if not, just remember to go through all the different possible combinations, and hopefully you'd still arrive at that combination as the correct completely factored form for this problem.